Good morning. This is Alan Chen from the Grades Lab at Georgia Tech. Today, I want to present you some exciting updates on the second generation SlothBot project. First of all, a table of contents. First, I want to introduce a smaller and far more elegant design on a physical robot. And we also want to talk about improved waterproofing mechanisms and hardware maintainability. On top of that, we also have software updates, including mass over-the-air deployments, or we call it the MOTAT system. And to top it off, we have a cherry on the sundae, a secret feature that we're going to keep it secret for now. So if you think about the SlothBot project, it's really, because it's a robotics project, it's by nature interdisciplinary. You have hardware, you have software, you have mechanical, you have embedded, all these kind of stuff. So it's really hard to integrate everything together in a smart and elegant way on your first try. So that's why for this second generation of SlothBot, we're really aiming at this problem. We're aiming to improve its functionalities, expandability, scalability, and also maintainability. Speaking of trimming down the size, thanks to our amazing mechanical engineer on the team, Hannah Phillips, we have managed to shrink down the size of the shell by at least 50%. Along with it, a 70% cut on the weight. So right now, the physical shell is really, really lightweight, really, really easy to maintain and manufacture. As for the PCB, we also managed to shrink the size by at least 68%, with a 28% cut on the price. That includes all of the electronics. And we did that while maintaining, if not improving, the functionality and robustness of the circuit. The new acrylic platform is also under development. We're projecting at least a 30% cut on both the weight and the size. On to waterproofing. The old approach was to use a giant plastic tube. The tube was good at waterproofing the precious electronics we have inside, but it was really, really hard to maintain. Once you get the electronics in, it's really, really hard to get it out. If, for example, we fry one of the components and we need to repair the board, it at least will take 2 or 3 persons to do that. So that's why we shifted to a box-based design. This box-based design uses a bunch of screws. It's much smaller than the original tube design, and it's also really, really easy to open while maintaining that waterproofing ability. So onto MOTAT, or mass over-the-air deployments. So before, for the original SlothBot, you have this linear program, right? A while true loop, and your main program runs within it. And then once you call this entry point, you run the loop. Forward, no multitasking. With MOTAT, however, we're introducing async IO into the life cycle. Basically, we are putting all of the tasks into these containers that will auto reload once you put any software updates onto the code base. So what that means is that once the SlothBot wakes up from its sleep, it will see if the code base has changed, right? If it has updated. If so, it'll pull in the newest code and start executing the newest code. This allows us to deploy the latest software to hundreds, if not thousands, of SlothBots out there in the field remotely. So this will be a big plus on the scalability part of the project. Onto our one more thing. And with that, we want to introduce Project Cecropia. And that's the cloud-based orchestrator for the SlothBot project. Have a little cute logo for it too. So right now you see on the background is the very orchestrator website that you can see and use at this moment for Cecropia. On the homepage, we have a very cute video of the original SlothBot. And you can also go to controller where you can put, we can queue up instructions for SlothBots to execute once they wake up. We can also visualize all the data collected by the SlothBots. And that includes different kinds of data. You can also select the agents that you're interested in. And also, of course, more features are under development. So for the next updates, what can we expect in a few months or a few weeks? Well, first of all, as we said before, we're redesigning the acrylic platform, so it would be much more lightweight and small. And we can also expect the SlothBot to be physically deployed in a lab environment. We're not ready to deploy them into real world in the tree environments just yet, but we're confident to deploy them into lab environments in the next iteration. We can also expect sensor and actuators integration to be coming soon. That means from the dashboard, we will be able to let the robot read data, send us the data, or move around the space. And of course, we will also introduce richer functionalities on Project Cecropia. And that is it for today. And thank you very much for tuning in, and stay tuned.